think it's towards the bottom or towards the lower half, yeah? Okay, so in set 59, which has a kind of brother in set 60, we'll do tomorrow, you're talking area between a curve and the x-axis. Tomorrow we'll do area between two curves, and not the axis. So the idea, though, is that area should be positive. And you do that by making sure the height needs to be made positive. The base of the rectangles. Now, when I say the height, remember, as always, area in calculus is done by the sum of many rectangles. And that's an integral. An integral comes, a definite integral comes from the idea of you're summing many base times heights. The base is dx. It's like a delta x, a width, but it's infinitesimally small. So small that it's not even 10 width pi. The height, the length of those rectangles, that's the f of x. All right, now that needs to be made positive. Let's go one together, just to remind you of the big idea. If I asked you to find the area enclosed by the x-axis and x squared minus 4x, the fact that they're saying the area, that means geometric area, and it needs to be positive. So it's not just this. You need to differentiate between where I give you this problem, and I just say, boom, crank it out, and that problem. Those are not the same. There's a lot of overlap, sure, but they're not the same. This, that can be negative. I don't care if that's negative. It can be whatever. I mean, integrals can be negative. Sometimes I want to know if it's negative, like a velocity problem or something like that. But if they say area, you need to take steps to make sure you're accumulating positive area. So let's graph this first. What does this graph look like? Describe the graph for me, please. A parabola with roots at 0 and 4. Opening up or down? Up. Okay. Okay, now, again, remember the big ideas here. You're way back in the day, we said, oh, there's this idea of infinite many rectangles, and we did all that summation notation work, which is tedious and laborious, and it's terrible. But we said, oh, there's a better way, a definite integral. Now, in this case, however, you can see that f of x is negative here. It's below the axis, so those are negative y's. So if I were to just mindlessly crank that out, this would be negative. And I don't want it to be negative. I want positive area. So I need to take steps to make the area positive. Well, the easiest way to do it is to say, I want the opposite of f of x to make the y's positive. The opposite then would be more like negative x squared plus 4x. You follow? Are you with me? What's the antiderivative of negative x squared? Negative 1/3 x cubed. What's the antiderivative of 4x? 2x squared. From 0 to 4. By fundamental theorem, do I put in 4 first or 0 first? 4 first. I put in the upper limit first and subtract away the lower limit. So if I put in 4 first, I get negative 64/3 plus 32. When I put in 0, I get a pair of zeros. Yeah? Finish the problem up with the common denominator. What is the common denominator? 3. So I get negative 64/3 plus 96/3. And therefore, the total area enclosed is 32/3. All right. Now, I think you'll agree that's positive, and that's definitely what it should be. Would you like to try one on your own? Try the next one on your own, then, or with your math amigos. This one will be considerably harder. So you want to picture first. What's the center line? -1. And if the amplitude is 2, then it's going to go up to +1 and down to -3, yeah? All right. The wave shape is positive sine, so it should look like that. What's the period of the wave? How do you find the period? Which of these numbers affects the period? Let's start there. 3. Okay, and is the period 2 pi times 3 or 2 pi divided by 3? Divided by 3. So the period is 2 pi over 3. Which makes that pi over 3. And so we're getting a fairly ugly-ish situation, I think you'll agree. Yeah? Well, this is a rough one to start back from breakaway. Okay? So let's go with then, actually maybe we should, that's okay. All right, now then, I actually have, this we said is pi over 3, right? So this is 6 pi over 18. Do you agree? Right here. Now, I have different situations. If I look at rectangles, I have some region that's below the curve, so I would have to do opposite F here. But then I have some region that's above it. So I'd have to do normal F there. And if I have to do some cases where I do take the opposite and make that F, and some where I do normal F, then that means I'm going to have to do some 2 integrals. I'm going to have to do at least 2, maybe even more. But to know where the region starts and stops, I need the zeros. Because those will be where I switch off from negated F to normal. You with me? So I need those dividing points. How do I find them? Set f of x equal to 0. Exactly. So if you do that, you'll find that you do have to execute trig skills in this path as much or even more sometimes than in pre-calc. So I'm getting something like 1/2 equals sine of 3x. At what angles is sine equal to 1/2? What kind of angles is sine 1/2 at? 5 or 3, 6s, 4s? 5 or 6s. It is 5 or 6s. Okay. 5 or 6 is definitely 1. So 3x could equal pi over 6, and this would all work out. Where else is sine positive? In what quadrants is sine positive? Second, okay? Because sine is like y, that's opposite. Opposite is positive in the first and second. Don't give me that, all students take calculus stuff. Okay? I don't do mnemonics, I do conceptual. So, do you not, is that not like your thought? That all students take calculus and everything? You're not? Okay, never mind. That's what House Saxon teaches, but obviously your teacher's going to do that. What is this angle? 5 pi over 6, beautiful. Okay, so I would get truth here if the angle was pi over 6 or 5 pi over 6, but that's what 3x would have to be, which would mean x would have to be pi over 18 or 5 pi over 18. So although you might have thought I was messing with you or making your life hard by that 5 pi over 18, I was actually throwing you a bone. 5 pi over 18, because I stopped it there, means I only have to do 2 regions instead of possibly even 3. All right. Now, this region in red. To make that positive, what would you have to do with the function? Negate it. So from 0 to, what's the dividing line between there? Pi over 18, I'm going to integrate 1 minus 2 sine of 3x. And then the next interval, from where to where? Pi over 18 to 5 pi over 18. Am I going to do normal f or opposite f? Normal f. All right. Now the beauty of this then is that we're also getting a little bit of u-sub practice here. Because we have a function within a function, now you might think, what's the function within the function? It's a big mess. This 3x, that's the function within the function. The negative 1 is a constant, no big deal, I don't care. The 2 is just a coefficient, the 2 I don't care. But the 3x represents function within the sine function, so that calls for u-sub. So what should we let u equal? 3x. Okay? Now if you remember your u-sub skills then, you then have to find for that u a d. If u is 3x, then take the derivative. And du is 3dx. Now I don't have a 3dx, I have a dx, so that dx will get replaced with du over 3. Okay. Now the minute you u-sub, you also are going to need to change the limits. If x is 0, u is 3 times 0, or 0. If x is pi over 18, then u is 3 times pi over 18, or pi over 6. If x is 5 pi over 18, then u is 3 times 5 pi over 18, or 5 pi over 6. Yeah? You with me? Okay. Now with all the substitutions, we'll get a different, and if we did this well, easier problem. 0 gets replaced by 0. Pi over 18 gets replaced by pi over 6. The integrand is still 1, still 2, still sine, but now instead of 3x, we're dealing with u. And that dx is 1 du over 3. So I'm going to pull that third out front, so my integrand is fairly clean, and I'm just going to put the third out front and du in the other. You with me? All right. The same kind of substitution stuff for the second interval. Pi over 18 becomes pi over 6. 5 pi over 8, or 5 pi over 18 becomes 5 pi over 6. The integrand is negative 1 plus 2 sine of 3u. Oops. Yeah, that's good. Sorry. Not 3, just u, right? And then again, I've got a du and a third out front. Careful, careful. Okay, have you ever heard the old adage, how do you eat an elephant? You haven't? Nobody's heard that? You guys read books at all? You're supposed to get home. You never heard that saying? How do you eat an elephant? One bite at a time. That's exactly right. Okay? You eat an elephant one bite at a time. That is right. Okay, when you get a problem this big, it's atrocious. You'll do it with God. I can't do it. Just one bite at a time. Little by little. Okay? So, but you better be careful. And me, gentlemen, I'm talking to you, sloppy gentlemen. Okay? So, here we go. 1/3. What is the antiderivative of 1 with respect to u? U. Okay? What's the antiderivative of negative 2 sine u? What was there before that yielded that derivative? 2 cosine. Is it positive 2 cosine u or negative 2 cosine? It is positive 2 cosine u, because that derivative would be negative 2. Okay, from 0 to pi over 6. Cool. 1/3. Antiderivative of the next. Negative 1's antiderivative is negative u. And is this plus 2 cosine u or minus 2 cosine u? Minus 2 cosine u from pi over 6 to 5 pi over 6. Now, sometimes when I use sub, then I sub back for u. Do I do that here? No. You don't, because we change the limits of integration to fit u. So we stay with u. We don't sub back, which would be an indefinite integral, or an integral without limits of integration. Okay? So we're subbing in here. 1/3 of When pi over 6 goes in, I have pi over 6 plus 2 cosine of pi over 6. I guess I'll take this one. That needs to be in parentheses. When 0 goes in, I have 0 plus 2 cosine of 0. You follow? Okay, plus 1/3. When 5 pi over 6 goes in, I have negative 5 pi over 6 minus 2 cosine 5 pi over 6. Parentheses minus parentheses, negative pi over 6 minus 2 cosine of pi over 6. Yes? Why would this one, when you anti-differentiate it, become a u? Think of it like a constant. First of all, what if I said integrate this? What gives you an integral of 1 is whatever the variable was. Right? Wouldn't the variable x to be x to the first? Now in this case, it's because we changed it to u, that's why. Okay? Thank you for asking and not just going along with it. Okay, because I do make lots of mistakes. Pi over 6 is fine. Boom, leave it alone. What's cosine of pi over 6? Root 3 over 2. So that's 2 times root 3 over 2. Minus, now I've told you over and over again, don't assume that when zeros go in, it's 0. Because cosine of 0, for example, is 1. And so this would be a minus 2 when I evaluate the cosine and distribute the negative. You follow? Okay. Close that, open up the third. Okay, negative 5 pi over 6 is fine. What's cosine of 5 pi over 6? Negative root 3 over 2. Geez, how many places to make a mistake here? This distributed with the negative would be plus pi over 6 plus 2 times cosine of pi over 6, which is what? So I've distributed the negative, so I have a positive pi over 6 and a positive 2. Now I'm doing cosine of pi over 6, which is root 3 over 2. All right. Gradually simplifying. In these parentheses, there's not any combining like terms to be done yet. I suppose you actually have. I see some sticky notes going on. I guess I didn't give enough room. Sorry. There's no combining like terms here, so I should just start distributing. I'm going to get pi over 18 plus 2 root 3. Actually, let's just call it root 3 over 3, yeah? Root 3 over 3 minus 2/3. Here I can combine like terms, so I'm going to hold off on the distributing until I combine like terms. For example, negative 5 pi over 6 plus pi over 6 is negative 4 pi over 6 or negative 2 pi over 3, yeah? Likewise, I get this is positive root 3 plus root 3, yeah? Do you agree with that? Positive root 3, the negative and the negative is positive, the 2's cancel out. So that's root 3, so that's 2 root 3. Are you with me? Good. We're almost there. When I distribute here, negative 2 pi over 3 times a third is negative 2 pi over 9. Plus 2 root 3 over 3. We almost done. What's the total of the pi terms? Negative 3 pi over 18. I agree. Negative 3 pi over 18 or negative pi over 6. Yeah? Okay, perfect. What's the total of the root 3's? 3 root 3 over 3 or root 3, and the total of the constants feels like just negative 2/3. You follow? Now the question is that positive? That's about 1.8. That's about a half. It feels like that is positive, so we're good to go. Okay, it's not very big, but the curve's not very big. So that's our answer. Now, your question might be, holy crap, should I be expected to be able to do that by myself? And the answer is yes or no. That would never happen on an AP test, but I guarantee you, at a lot of colleges, and most colleges, that's considered a rigorous problem. And so you would be expected to do that in college for sure. Okay? I want you to be prepared. Let's go on to something easier, shall we? Right above this is inverses. And there are a lot of ideas about inverses. You might write in the inverses, right, just in the objective section. The idea of inverses is there are lots. You switch x and y. There's symmetry about y equals x in the graphs. A function composed on its inverse should undo each other and give you the original value of whatever you put in. What other, gosh, and then there's this idea which we'll talk about here. One of the ideas we talked about is if you take a function and invert it, is the new function is the inverse of function. Now let me say it this way here. Say the parabola, yeah? If this is the original function, then what does the inverse look like if I switch x and y? Instead of a vertically opening parabola, it's a horizontally opening parabola. Okay? Now I think you'll agree that this inverse is not a function, and that's because the inverse fails the vertical line test. The inverse fails the vertical line test. Are you with me? Now we can trace that back to a characteristic of this guy. The inverse fails the vertical line test because the original failed the horizontal line test, and that means it's not one-to-one. Horizontal line test. One-to-one is just a way of saying for any x there's one y, there's never this two y values for any one x value. That's not one-to-one. All right? So if the end of the day that you'll need for this problem is if the original is one-to-one, then the inverse will be a function. And if the original is not one-to-one or fails the horizontal line test, then the inverse is not a function. So, x to the fifth, for example. Let's show you what I mean here. Use your knowledge of these graphs to decide if the inverse would be a function. If the inverse is going to be a function, the original must be one-to-one. So, do you know what x to the fifth looks like? Looks a lot or not just like, but a lot like x cubed. It's just steeper growing on the outsides and flatter on the insides. Okay? So, is that one-to-one? Yeah, it passes the horizontal line test, okay? So, f is one-to-one, so f inverse is a function. That's not hi, Ford. Okay, that's what we're looking for. So, secant. Do you remember the secant graph? What does it look like? Give me some. Yeah, there we go. Okay, I'll take it. Okay, is that one-to-one? Does it pass the horizontal line test? No. Okay, so this is not, f is not one-to-one. So f inverse then is not a function. If I were to invert that, it would look like this kind of thing, and obviously that is not a function. You with me? That's the thing I'm looking for. Try the other two on your own. Ready? Charlie, ready? Charlie, ready? Super. I love Thanksgiving. Okay. Absolute value. Do you agree that x cubed is a normal snaky kind of shape? But absolute value, what does it do to the graph? Makes all y's positive. So is f 1 to 1? F is not 1 to 1, so f inverse is not a function. Okay? X cubed plus x, fight the temptation to graph that with your calculator and think your way through it. Now I understand you don't spend nearly as much time learning how to graph stuff you're not familiar with as we did back before we had graphing calculators. So your thought process might go something like this. You might have factored it and you said, well, it's got a 0 at 0, yeah? And you might be thinking, well, shouldn't it be doing some turning and dippity-do stuff? Well, this is how you would, or at least an old guy would think about this. X cubed looks like this, and x looks like this. And if you put those two together, it doesn't cause turning. It causes more growth here. This guy wants to grow positively, grow positively. When you put them together, it's going to grow positively just even faster. And this wants to go negative, go negative. It's going to go negative even faster. So it's going to look like a cube graph, just even steeper. You get dipsy-do stuff when you start trying to get terms that fight each other. This would take turns because x squared wants to go up, x cubed wants to go down. If you add them together, then you get a little partial dipsy-do stuff. All right, so that's, at any rate, hopefully you could get through that in fairly good amount of time, but the function is 1 to 1, so the inverse is a function. Okay. Let's go to this guy. Would you find the definite integral rules section? I think this is the one right below the objective. Would you try this on your own? I would like to see for myself how we're at, where we're at on these babies. So getting you started, the question involves a function within a function, yes? Yes? Okay, 4 minus x inside x. What's the technique for dealing with an integral when you have a function within a function? U sub, it's U sub, okay? So if you're not starting off with the U sub, start off with the U sub. If you have a function within a function, you use U sub. Be careful with your du, there's a negative on there. like this shouldn't be hard, but they are. You have to be very detail-oriented. So this is what I got out of after my use set. You should have picked up a negative on the du, because the derivative of 4 minus x is a negative. So when you isolate positive dx, you get a negative du. Still not out of the woods. We're thinking to be done here. Are you ready? Should we talk about it, or give you another minute to finish it up? Another minute. Great. So you're still really only about half in. There's still a lot of places to screw up. Ready to tap out, or should we go over it? Okay? All right. So right now, before I go trying to connect to what they gave me here, this to me is an issue. Going from 2 to negative 2 is going left. And if I go left, that's a negative dx, and that's bad. So what's the process of switching these to the way it should be? If you switch these, then you negate it. Now, if you negate it, that actually knocks out that negative, and so that's all great. It's the same as negative 2 to 2 of normal f. And the two negatives knock each other out. You with me? Now, that said, I don't have negative 2 to 2. I have the area from negative 2 to 6. Whatever, I have no idea what the curve looks like. I cannot know. And I have the area from 2 to 6. Okay? Whatever that might be. So, I get the area from negative 2 to 2 by talking about how these compare. Isn't this the same as if you went all the way from negative 2 to 6, the whole, think of it just in terms of segments. Negative 2 to 6 would be that whole way, and then take away 2 to 6. And that would give me the part that I'm looking for. Negative 2 to 2. You follow? Now, what is negative 2 to 6? 10. And what's 2 to 6? 3. And so our answer is 7. All right. And that's how it would be done properly. Okay? Now, just so we're clear, in terms of test points here, there's only so many ways to combine 10 and 3. You know, I mean, I'll get people that say, well, I know it's some combination of 10 and 3, so I'll go 7. It's highly possible that on the test you luck out and guess 7. Now, if you luck out and guess 7, without all that work, you will get at most 1 out of 5. I'm not giving you points for luck. This class is about skill, okay? So, if you're thinking, oh, I just put them together and I got the right answer, he's crazy, I don't need to do all that stuff. Well, you do need to do all that awesome stuff. All right? Boom! Let's go on to something a little new, and it's at the very start. I didn't make this a full note sheet. I guess I should have, but it's not really in the book. It's me throwing in. Some books call it the total change theorem, the net change theorem. Some books just call it fundamental theorem. But it is going a little something like this. If you're given a rate that's not constant, then calculus is called. Right? In Algebra 1 and pre-algebra, if I said he goes 30 miles an hour for 5 hours, boom, done. or if I said he does 3 problems a minute, for 5 minutes, boom, done. Those are not hard problems. They're constant rate problems. There's nothing to it. Calculus is called for when I say, well, his rate is constantly changing. Now figure out how much he did. Well, that calls for a lot of little calculations. His rate here times a little amount of time. And then his rate here times a little amount of time. Then adding infinitely many of those. Well, that's what an integral does, right? So if you're given a rate that's not constant, then you can't do a single rate times time calculation to find out how a thing changed. You know, whether you figure out how many problems are done or how far he went. Rate times time could give you a lot of different results depending on the problem, right? If you have a rate that's not constant, you have to do infinitely many calculations of rate times. Now, this is normally a time frame, so a change in time. Actually, I'm going to rewrite that as delta t. Some rate times some time interval. But when we take that infinitesimally many, I can only say, you know, for 1/1000th of a second, then that delta t becomes more of a theoretical dt. And if I want to sum all those little rate times time calculations, that's where an integral comes in. That's what that integral stands for, S, for sum. It's the sum of many rate times microscopic time calculations, all right? Now, let's introduce the idea of a dummy variable here, okay? If R is a rate at which something happens, whether it be traveling or problems done or people coming into the store or people going out of the store, or it could be a million different things, but it's a rate. Then if I talk about integrating from time 0 to time whatever, let's say 4 r of t dt, and this is the net change from time 0 to time 4. Maybe it's how many problems get done from 0 to 4 minutes, right? If I did something like this, I'm going to write some bad calculus momentarily. Just pause for me and I'll fix it in a second, okay? If I did something like that, that would make sense then that it would be, instead of net change from time 0 to time 4, net change from starting point up to any time. You with me? And depending on when I put that ending point, 4 seconds, 5 seconds, it would be different amounts of problems done, whatever the case. You with me so far? Okay. Now, a dummy variable. This is bad calculus. In fact, it's just bad math altogether. Because t is being used for 2 different ideas. It's used to represent the rate function variable. And it's also used to say up to the whatever endpoint. Now, because that can't be used twice, we create what's called a dummy variable. We're going to use a dummy variable inside the integral. So we would say, I want t to be the final variable after I integrate that goes in, right? So that t needs to stay. But this, I'm just going to let u kind of hold the place. It doesn't have to be u, it could be x, it could be a lot of different things. So I'm going to use u. I think I should use that's it. Okay? Now, it still represents change from 0 up to certain some certain time. U is just kind of making the variable, but if you think about how this would work at the end, wouldn't this be some antiderivative and t would go in? So at the end of the day, t would be the variable of interest. Wouldn't u's just kind of temporarily holding a place until I find the antiderivative and t gets substituted in. So at the end of the day, this would represent the net change as a function of t, the ending point t. Okay? Now, if I told you then, hey, a kid does problems in 7th hour at this rate, then what would that represent? R is the number of problems per, let's say, I'll say number of problems per minute that the kid does in 7th hour. What does that represent? So think of the units. This is problems per minute. And that dt has units, so it has units of minutes. So when you do all these little rate times time calculations, you're getting problems. Problems done. Problems done when? Okay, problems done in 15 minutes. So would you say that represents how many problems he has done after 15 minutes? How many say yes? Okay, that's good. It's not how many problems he has done after 15 minutes. It's how many he does in 15 minutes, but it doesn't have to do, it's not totally how many he has done, because we also have to know how many he started with. Okay. This does represent number of problems done in those 15 minutes. But it doesn't represent how many total problems he has done altogether, because he might have started with 3 problems done in class, right? So in this next case here, you sometimes are going to use an initial condition to find a new amount. If you want the number of whatever's done as a function of t, then it would have to represent or be found by taking the number you had at time 0 and the change from time 0 up to some certain point, r. Okay. Now this is the starting amount, plus this represents the change in the amount, and together those two things, the starting amount plus the change in the amount, gives you the ending amount. You follow? So do you have a homework set? Do we still have to do questions on? Gosh, it's been so long. Let's just say, do you have, I don't even remember. Did we get through all questions? Are you totally caught up? Or do you have a set in front of you? Do you have set 59? Oh, that's right. I got you. So I don't have 59 from everybody. I have 58 from everybody, but not 59. All right. I would like to do one of those together, but I guess I'll have to lead you to it. If you have set 59 questions, let me know. The key is online, has been online all break. So if you need explanation, let me know. But I want set 59 done today. Unless you already turned it in. Let me know if you have questions on set 59. All right. Sure.
There's all of my things.
Oh, super. Thank you. Appreciate it.
Oh, you have to do plus the integral, so it's that, right? Okay, that makes sense.
Friday.
I broke it.
Okie dokie. I understand you might be a little rusty, it's been a long break. So, 7th hour, if you're really rusty. You may use a calculator on those 1 and 2, by the way. Hi.
Can you show where we get this equation?
I would call it, no, you don't. You do need to show where you get your answer.
Yeah, so we can just use this equation.
Right.
Alright,
Yep, okay.
thank you.
You bet. Do you want to talk about number 1 together real quick, since I don't have any questions? Okay. So, oil's pumped out at a rate of blah, blah, blah gallons per minute, where T is measured in minutes. How many gallons are pumped out? So I want change based on a rate of change, yeah? Which means I use an integral. They don't say anything about a starting condition. They just say how much is pumped out during the time interval. So this is not an initial condition plus change. I just want to know change, yeah? So how am I going to do it? Take the integral from 0 to 6 of that guy. That's, by the way, negative 0.1 t. You may use a calculator.
Ready, begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
They just want to change.
Today is the last day for 8th graders ICAP. If your last name is S2C, please report to the auditorium for 7 hours.
So
And any other
use a calculator to evaluate the integral.
Tomorrow, Midshipman August Roberts will be here to discuss the Naval Academy. He can answer all of your questions for the guidance on how to apply to any academy. Stop by counseling to get a pass.
If you are in or interested in stage crew for the musical, we will meet today and Thursday this week. See Mr. Murphy for information.
Don't miss out on the Cyber Monday yearbook today. Use the yearbook link on the school website by November 27th to get $5 off of your yearbook. Make sure to use the code THANKFUL in all caps to get your discount. Get your yearbook before they sell out.
Senior high students, we are in need of more peer tutors, especially for social studies and science. Please see Mr. Schmeck if you'd like to help out.
Jacqueline Jacks. Congratulations to Taylor Herbig, Eliana Thompson, Katie Herbig,
You need to be able to evaluate an
Katie
integral with a
Livingood,
calculator.
Molly Rogers, Marley Somers, and Corinne Zapico for winning the small schools division at the Nike Cross Country Regional Southwest Casa Grande, Arizona over break. This is an impressive accomplishment and the best team finish in our school's history. Taylor, Katie, and Molly ran their career best. Caleb Fagan also ran in the small schools division and finished his cross-country season by breaking his PR by 12 seconds. That's all of your announcements. Have a great day.
Cool. You have about 4 minutes. We can get through number 1 together, and then number 2 will go well. So did you get the integral put in? Okay. Okay. Good deal. We're going to need to come back to that. What'd you get for your answer to the nearest gallon? 78. It was 77 point something, something, something. It is 78. All right. Now, that was just change in the amount. If they want amounts, then you have to talk about starting plus change. In this case, for example, if there are 200 gallons to start with at time 0, how many gallons are at time 20 minutes? Then you would, the amount at time 20 would have to be the amount at time 0 plus the change in the amount, which amounts to a whole bunch of rate times time calculations, which is what the integral does. So what's A at 0? 200 plus the total number of change, or how much was pumped in, which we do by integrating from 0 to, not 6 anymore, but 20 of that same function, 20e to the negative 0.1t over 1 plus e to the negative t. If you want, you could kind of retype over that previous 6 with the 20, and then add the initial. $200. So I'm getting something like, what do you get here? Let's keep rounding to the nearest gallon, shall we? 361? I agree, 361 gallons. Normally you would give 3 decimals, but let's just be consistent and keep rounding. Write an expression involving an integral that gives the amount of oil in the tank at any time t. Don't get to use the dummy variable, right? So again, the amount at any time t is the start plus the change. The starting amount is that varying or always the same? That's 200, okay? But the change depends on the time frame, from 0 to when. And the when is variable or t. So we're going to go from 0 up to any time t. Now if I use t there, then I can't use t twice. I have to use some other variable here. So you could use x or u or whatever you like. I'm going to use x this time, just because it hasn't been used, and I just want to communicate it doesn't have to be u. It could be a lot of different variables. Dx. Now, it wouldn't matter that x is in here, because once I integrate, t would go in, and the final answer would be that's it. Have a great day.
That is like classic here right there.
Dude.